Algorithm for finding the busiest period? I have some data like this. I will attempt a representation to make it clearer. So in the example case, 8 to 9 is the critical period if the second scheme is used because all the points are active. What is a fast and good way to solving this problem in Python? I am thinking of using dynamic programming, but are there other approaches that are suggested? My approach until now. I was thinking more from a real-time perspective. So, whenever I get a new point, I do this, assume I already got 2 to 10 and I get 3 to 15, then I pick the max of start and min of n, so this case it is 3 to 10, and increment this interval's count to 2. Then the third point comes in 4 to 9, pick the max which is 4 and the min is 9 and update the value 3 to 10 to 4 to 9 and update count to 3. Now when 8 to 14 comes in, I pick the start of this interval is greater than 4 to 9 and the end of this interval is less than 4 to 9. In this case, it is not true, so I will create a new bucket 8 to 14 and I put the count to 1. This is not the entire algorithm but should give a high-level idea of what I am doing here. I will see if I can sketch the pseudocode.
Get it? So you need to transform this into, and then you simply iterate through, counting up when you see a plus and counting down on. The busiest interval will be when the count is maximum. So in code, runtime complexity is n plus n, log n plus n plus n plus n, or O n log n. It is also possible to convert this idea into an online algorithm if you don't have the complete list of intervals at the start of the program, but is guaranteed that incoming intervals will never be scheduled for a past point. Instead of sorting, you will use a priority queue. Each time an interval comes, you push in 2 items, the start point and the end point, each with a +1 and -1 respectively. And then you pop off and count and keep track of the peak hour.
I would start by thinking of the busyness of a point x as the number of activations to the left of x, minus the number of deactivations to the left of x. I would sort the activations and deactivations by the time at which they occur, in O log n, time. Then you can traverse the list, tracking the number active, y, incrementing and decrementing that number with activations and deactivations passed. The busiest period will be the points at which y is at its maximum. I can't think of a solution off the top of my head that is better than O log n. The brute force would be O n squared.
Here's what I was thinking for the bin-based approach, and adapted to handle ads dynamically, basically what RK was saying, I believe. Updated, only sort on call to get _max, and use defaulted to int.
I thought you could perhaps use a set for this, and it would work if you assured that all periods intersect at least one point. However, this does not work as soon as a period does not intersect. You may be able to add additional logic to cover this, so I'll post what I was thinking. Note, this does not include the 11 to 15 period. You're probably best off just creating bin pairs as mentioned by RK.